This lesson, we will focus on direct and partial variation. So the difference between them is direct, they go through the origin, and partial, they do not go through the origin. And similarity between them is direct and partial variation, they both have straight lines. Let's take a look of one example of a direct variation. The story is Bernadette joins a health club and receives complimentary massage. Each month, she receives 5 complimentary massage. So look at the table. Whenever we have 0 month, she will get 0 massage. When number of month becomes 1, she is going to get 1 times by 5, which is 5 massage. When the number of month becomes 2, she's going to get 2 times by 5, which is 10 massage. And number of months becomes 3, that will become 3 times by 5, which is 15. And now let's use this table of values put into a graph. So let's look at the graphical representation. So number of months is 0, then she's going to get 0. Number of months is going to be 1, she's going to get 5. Number of months is 2, she's going to get 10. And number of months is going to be 3, she's going to get 15. And 4 will be 20. So the line continues on. As you can see from this graph, this is a straight line which goes through the origin right here. So we say this is a direct variation. So let's look at the symbolic representation. So we can use the equation now. So we say the equation can be number of the massage equals number of the month times by 5. There's another characteristics of the direct variation. Let's go back to the table for a second. So if it's a direct variation, the ratio will be the same. So let's take a look. This is 1 to 5. This one is 2 to 10, which is equals to 1 to 5 because they both numbers can be divided by 2. 3 to 15, both of them can be divided by 3. The ratio is going to be 1 to 5. So if this is a direct variation, the ratios will be the same. All right, now let's take a look at the partial variation now. So the partial variation, let's look at the example here. Kate usually runs 4 kilometers every week. Next week, she begins training for the marathon. Kate will add another additional 2 kilometers every week to her run. So let's look at the table here. So initially, she is going to run 4 kilometers, right? And after a week, besides the 4 kilometers that she's going to run 4 plus 2, the additional 2 kilometers, which is going to be 6. The next week, she's going to run 6 plus another additional 2 will become 8. And the next week after that, she's going to train herself to run better. So, and longer distance, so it's going to be 8 plus 2 is going to be 10. Now, let's put them on the graph now. Then you will see 4, 6, 8, 10, and 12. They still form a straight line. However, this time, as you can see, it doesn't go through the original. The y-intercept is actually on 4, so we know this is a partial variation. And now, let's look at the equation representation now. So if I want to look at the equation representation, you will see number of the kilometers that she's running is going to be number of the weeks times by 2 plus 4. So that means there is a y-intercept other than 0. So this is going to call partial variation. And there's another thing. Let's go back to the table now. If we look at the ratios, this is 1 to 6. This is 2 to 8, which is 1 to 4. This is 3 to 10, and 3 to 10 cannot be reduced. As you can see from here, 1 to 6, it's not the same thing with 1 to 4. It's not the same thing to 3 to 10. So we know this is partial variation. All right, let's look at this comparison. So direct partial variation, they are both straight lines. Direct go through the origin. Partial do not go through the origin. And so basically, it's direct variation. There's no fixed cost. And partial variation, there will be a fixed cost. Let's look at the equation here. Equation will be mx, but there is nothing here. It's adding a 0 as a constant. But for partial variation, you will definitely have a constant b that is rather than a 0. Now let's look at an example. Our telephone company offers a plan that charges 12 cents per minute for long-distance calls within Canada. So that's complete the tables. So if I do not call them at all, that will be 0 minutes. Then I'm going to pay them anything. So the cost will be $0. If I call for 5 minutes, then I would have to pay 12 cents per minute. So it's going to be 0.12, 12 cents per minute, but I have to times by 5, which is going to be 0.6. Next one, I will do 0.12 times by 10 minutes. I'm going to pay them $1.2. And then the next one will be 0.12 times by 15, which you're going to get 1.8. You have to pay them $1.80. And next one, you get times by 20, you will get $2.40. Next one, times by 24 is going to be $3. Times by 25, sorry, and 12 cents times by 30 minutes is going to be 3.6. 12 cents times by 35 minutes is going to be 4.2. And 12 cents times by 40, you're going to get 4.8. After we complete the tables, then we're going to graph the points on. So on the left-hand side, it's called cost, which is a dependent variable. On the bottom, which is the independent variable, so that's called them duration time. And put in the brackets minutes. And that's a variable t. So put the t here and put the axis here. That's called c. That's the total cost. So it'll be 0, 0, 5, 10 to 1.2, 1.8, and so on. Because time can be continuous, so we're going to draw a solid straight line. Okay. And remember, there's an arrow on the other end because the time can move some, but this end on the origin has to be a solid dot. So let's look at the first differences. So what are the first differences? The first differences are talking about the differences between the y values. That means how much do you go up each time. So let's look at the first difference. The first difference will be from 0 to 0.6. So from 0 to 0.6, we're going up by 0.6. But mathematically, how do I write it? I will do 0.6 minus 0, which is 0.6. Next one, from 0.6 to 1.2. Then you will say you go up by 0.6 again. But mathematically, you have to write down 1.6 minus 0.6, which is 0.6. So if you do all the calculation, you will get 0.6 all the time. So as you can see, there is a common first difference. What does that mean? That means this is going to be a linear relation. That means it is a straight line. But before we finish all the first differences, just make sure you always go up by the same amount for the independent variable as well. From 0 to 5, you add a 5. 5 to 10, you add a 5. 10 to 15, you add a 5. You have to make sure every single one of them, they go up by the same amount before you can say there is a common first difference. And so what kind of relationship does this one exist? It's a linear. Because they go through the origin, we say that's a direct variation. So how do I write the equation now? So let's look at this. If I say this is t minutes now, then I will write down 0.12. I have to times by t equals to the total cost, c. So my equation will be c equals to 0.12 t. Next one. A soccer league holds an award banquet that at the end of the season, the banquet hall charges $40 per person for the meal plus $500 of the use of the banquet hall. That really means this: even though you don't invite any person to come in, you still need to pay them $500 just to be able to use the hall. So if I have 0 people, I still need to pay them $500. But if I have 25 people coming in, then I have to do 25 times by 40, because $40 per person plus 500. This will give you 1,500. Next one will be 50 times by 40 plus 500. Then you get 2,500. So the next one, you will do 75 times by 40 plus 500. You're going to get 3,500. 100 times by 40 plus 500, you get 4,500. 125 times by 40 plus 500, you're going to get 5,500. So that's finish the graph. So 0 is 500, so it's right there. As you can see, this one doesn't go through the origin now, right? Because y-intercept, which we call the c-intercept here, is actually at 500. And 25 people is 1,500. This point is not very clear, so let's try another one. 50 and 2,500. And 75 is 3,500. And 100 people coming in will be $4,500. And 125 will be here. But this time, I cannot make a solid dot because you cannot have 2.2 people coming in. So we have to make a dotted line. Dotted line really means not every single decimal point on this solid line, on this line will work because we only can accept whole digit 1 person, 2 people, 3 people, not 4.5 people. Then the next one we do is we have to figure out the first difference now. Once again, before you figure out the first difference, you want to make sure that the x value goes up at the same amount. So as you can see here, let's add a 25, add a 25, add a 25, add a 25, add a 25. That means the independent variable does go up by the same amount. So let's look at the dependent variable. 1,500 minus 500, 1,000. 2,500 minus 1,500, 1,000. And 1,000, 1,000, 1,000. So once again, we say there is a common first difference. This means this is a linear relation. It is straight line. So this is linear. However, this time, because they didn't go through the origin, right? This is 500. So we say that's partial variation. Let's figure out what would be the equation now. So if I say number of people is n here, then I will need to do n times by 40 plus 500 will equals to my total cost, C. So C equals to 40n plus 500. So in summary, let's sum this up. Direct variation, straight line, go through the origin. Partial variation, straight line, but does not go through the origin.